Genesis is a photopolymer development resin base for use in formulating new solid-loaded UV-cured resin for 3D printers. With Genesis, you can mix in solid powders, ceramic, and metallic powders directly into the Genesis resin. Genesis is a unique formula that can be burnt out in a furnace with little to no remaining binder left over. The applications for unique resin materials exist in many differing industries, including aerospace, defense, dental, energy, biotechnology, and many more. Depending on your material development needs and 3D printer capabilities, Tethon 3D sells standard, flexible, and high-load Genesis resins. All of these resins work great when developing new materials with the Bison 1000 DLP printer by Tethon 3D. The Bison 1000 is fully customizable with onboard controllable print settings. The combination of using Genesis and the Bison 1000 is a great tool set for any material scientist in the UV 3D printing space. Genesis formulas can also work with other DLP, SLA, clip, and LCD hardware. Standard Genesis is great for solid powders that do not need a high volume of powder to resin, under 40% by volume. It also is great for materials that do not wet very quickly. High-load Genesis is for resins that need over 40% by volume in powder loading. High-load Genesis has special additives that allow for even dispersion of the powders in the resin while mixing. Flexible Genesis is our lowest viscosity base resin and is also capable of high loading levels. The advantage when using flexible Genesis as a base is it makes a semi-flexible object in the green state. This material quality can be great for powders that cause our high-load Genesis to stiffen and makes them hard to remove from the build plate or are too brittle. It has also been known to have higher loading capabilities for materials that affect the rheology of high-load Genesis. Genesis materials do not 3D print on their own, but provide a starting point for photopolymer resin research and development. They need solid powders loaded into them to help them build up enough thickness to print. Genesis-based resins work from 365 nanometers to 405 nanometers. Please use an appropriate mixing method for your materials when loading into Genesis. High shear, vacuum rolling, and ball milling have all worked well with mixing. Before using mesh editing tools, you will need to turn on support mode. First, we will start with shrink wrapping our 3D model. This should fix most geometry issues that prevent you from printing your object, or if you're finding you're having trouble attaching supports to your model. Increasing the resolution will decrease the size of the triangles being applied to your model and will more accurately capture finer details. As you can see for this model, it's a bit overkill, but it shows the resolution that the program is capable of. When dealing with a model whose poly count is too high and bogging down your system, you will want to use the Reduce Mesh tool to decrease the number of polygons on your object. The higher you increase the percentage slider, the lower resolution the end result will be. You may have to test at different percentages to find the best fit for the object you are reducing. The next step is to hollow out your mesh. Hollowing out your model has the benefit of reducing the amount of resin needed to print your model, but also may be necessary to print in certain materials. Consult the material guidelines of the resin being used to determine the correct wall thickness for your print. Turn on, switch to transparent view model to see the end result after it's finished computing. Before adding drainage holes, I like to create infill for the object. Creating infill will give stability and strength to the print after hollowing it out and may be necessary when printing in certain materials. Once it's been added, you can move and or delete the different parts of the infill where necessary. To allow resin to escape out of a hollowed out model, we are going to need to add holes to the object. You will need to add holes to both the top and bottom sides of the model to allow the resin to flow freely. Once you have placed drainage holes, hit the escape key to exit the tool, and then you are free to select, move, resize, and even delete the holes you have placed. You can also boolean out the drainage holes from the model. This will allow you to export the object with the holes intact, but be aware that this is a permanent change to the model that you won't be able to edit later. If you ever have a need to separate objects that have been combined together, you can use the Split Disjoint Shells tool. Note, this only works for objects that have been combined together. Anything that's been booleaned together will not separate. Once you've split the objects apart, you can use the Batch Process tool to lay out and add supports to all of your objects at once. This helps reduce the amount of time spent in the program and get to the printing process quicker. Inversely, you may want to do a quick mashup of multiple objects, and you can do this by selecting everything you want to join together and use the tool Join Disjoint Shells. At Tethon 3D, we sell a variety of materials which are capable of going from a green state or pre-fired to a bisque state or fired when heated in a kiln or oven. When going through this process, the print will shrink, and this amount can be anywhere between 4 and 17%. To account for this, in our Tethonware software, we will need to use the first scaling category, which is scale by factor. The most basic option will let you scale uniformly in all directions. So, for example, if your material you are using shrinks 12%, you will want to change the setting to 1.12 and click Apply. For materials like vitrolite that shrink much more in the Z dimension than the X or Y, you will want to utilize the second option in this category, which is scale per direction. For the X and Y, we will scale to 1.09, and for Z, we will scale to 1.14 to account for the extra shrinkage. Be aware that both the orientation in which the object was printed and the orientation in which it's being fired can have an effect on the scale, and some trial and error will be needed. The second scaling category is scale to fixed size. Sometimes when bringing a file in from one program to another, its scale can change depending on the units the software uses. This option will allow you to scale the object to a specific size by the dimension of your choice. Turning off scale proportionally will allow you to stretch the model in the individual X, Y, or Z axes. The last scaling category is scale to build platform. This allows you to scale the object as large as possible in its current orientation. You can even set padding if you want to keep your model a certain distance from the edge of the build platform. Using the scale to place multiple items option will have Tethonware calculate an approximate maximum size for printing a specified number of objects. For both of these, changing the orientation can change the final result. Given that many factors can affect how the object shrinks in the kiln, or you may in fact be creating a new material, you will need to find the shrink rate of the material on your own. One way you can find the shrinkage in the Z dimension is by scaling a model incrementally vertically, like you see here. You may also have an object with fine details that you may need to work with other objects, like the threads on the nut you see here. What you'll want to do for this is scale it up 1% multiple times. The one that threads best with the intended matching bolt will be your best estimate for shrinkage. Next, click on Generate Supports. This will generate supports based on the selected support profile, which you can edit and save multiple of. The supports you need for your model will be dependent upon the material you are using. To make changes to your supports, click Edit Points. When turned on, you can click and drag to marquee select all the points you would like to remove and click where you would like to add supports. When you are finished, click on Apply Changes for the edits to take effect. As you can see, some of the supports are red, which means they are intersecting with your object. You could go back into edit mode, but you can also individually select and delete these when necessary. Changing the support point density will increase or decrease the amount of supports that attach to your print. If you're finding that your print is falling off of the supports or are too hard to remove, you can increase or decrease the tip size to fix these issues. Increasing the critical build angle will allow for more of the object to be considered for support points. You may want to increase this for heavier prints. For sampling strategy, generally you will want to use creases and surfaces for your print. For fewer connections to smooth surfaces, choose creases only. And to retain sharp edges or details, choose surfaces only. The different surface sampling options change how the support points lay out on your model. Selecting random will be faster and place the points randomly across the model. Selecting grid option will take longer to calculate and have a more dense and organized support layout. Changing the support generation strategy will change how the supports lead to the points. Split style scaffolding is your basic support setup and good for most prints. Single supports only does not connect the supports together and just go from the base plate to the object and may be best for smaller and lighter objects. Finally, lattice has much denser interconnected supports that work better for heavier objects. Changing the pole diameter will increase or decrease the thickness of the support column, whereas pole widening factor will add a tapered increase to it. Increase the place above base value if you want more room between your print and the base. This may help with support removal. Enabling internal supports allows the supports to propagate inside the model or outside where they do not connect with the base but the model itself. Changing the height and the diameters of the foot is another way to increase the strength of the connection to the base. Adding a base plate to your print can help the initial layers to stick better to the print. Among the many options, you can either have a silhouette of your model as the base plate or set it to fill the entire area for either a larger object or filling the print bed with many objects. Once you have the majority of the supports set, you can now individually edit the supports by clicking on one and changing the values in the screen that pops up on the right. Hit apply for the edit to take effect. To edit the base, as mentioned earlier in the video, select it and, like with the supports, make the necessary changes and hit apply.
Remove the build plate from the printer. Apply a bead of bison grip across the build plate. Use the provided squeegee to spread the bison grip into a thin layer. Once done, you are ready to start printing again. Once printed, remove the build plate from the Bison 1000. Next, remove the print from the build plate. Now you want to cut off the remaining supports on the part. Wash the part in IPA or Tethon 3D print wash for faster results. Use a brush to remove any remaining resin on the part. The part is ready for the kiln. Refer to our user guidelines for the firing cycles. Optional, use firing supports for unique geometries. Optional, once sintered, the part can be glazed or slipped. Slipping can help further densify the part. After slipping, the part needs to be sintered again. The part is now finished.